Hello Year 12 and welcome to our first video on MM5 applications of trigonometry. Now I'm sure you've done some trigonometry before, some reminders about these things. We are looking for the ratios, so we certainly are going to be using trigonometry to describe the ratios of sides of right angle triangles. So opposite, adjacent and hypotenuse. Opposite and adjacent are relative to some given angle, which we usually abbreviate to theta here. And the hypotenuse is the longest side of a right angle triangle. It's opposite the right angle. Okay, if I drew an arrow through the right angle, it would hit the hypotenuse. Okay. Every now and again, a bit of Pythagoras sneaks in here too. Remember, which also relates to right angle triangles. C squared equals a squared plus b squared. So, sine, cos and tan, right? In full, sine, cosine and tangent. We're going to call them sine, cos and tan. We need to remember these relationships. That sine is the opposite on hypotenuse, cos is the adjacent on hypotenuse, tan is the opposite on adjacent. You do get these on your formula sheet, but well, look, it's difficult if you go looking for them every time you've got to use them. So get in the habit of remembering them. Some old hags can't always hide their old age, or some sort of mnemonic like that is a pretty common way. Some people just like this this acronym SOHCAHTOA. Some people have a different mnemonic, or some people just remember the ratios. Anyhow, find the missing pronumeral. Example 1. I have here an angle of 45 degrees 28 minutes. So we've got to be able to do that in our calculator. I have the opposite side here, right? Because if I drew an arrow through that angle, I would hit that side. That's the opposite. And this side is opposite the right angle. That's the hypotenuse. So opposite and hypotenuse. Opposite hypotenuse is sine. Okay. Sine. What's going on there? What has happened to my pen? Sine. I'm cranky now. Oh, it doesn't scroll the pen either. Hang on. Sorry guys, technical issues. Now, I have here the opposite and hypotenuse, so sine of 45, 28 equals d over 6.8. Right, do that substitution. That means that now multiply both sides by 6.8. d is 6.8 times sine of 45, 28 degrees, 28 minutes, sorry. So, out comes the calculator. 6.8 times the sine, what are we hiding here? 6.8 times sine, 45 DMS, 28 DMS again. Now, it doesn't give you the little apostrophe there for minutes that we're so familiar with. It does another degree symbol. It's just a quirk of the calculator for this and the Casio. Anyway, here we go. Now, in fact, if I'm a bit sensible, I should look at this and go, well, you know what? I reckon it's certainly going to be less than 6.8. That's the longest side. I think it's going to be like 4.5 or 5 or something. I think 5 sensible guess. Ooh, 4.8. 4.8 meters. Right, 1 decimal place. Same as the question. There we go, makes sense, looks sensible. A couple more of these. Now here again, I have the opposite, but this is the adjacent. So, the tan, that means opposite and adjacent, tan of 24, 47 is 13 over k. Now because k is in the bottom here, I'm going to multiply both sides by k, then I'm going to divide both sides by 10, 24, 47. You can think about swapping these two places over. Anyway, it means that k is 13 over 10, 24, 47. Right, calculator needs to come out again. 13 divided by, I don't put the fraction in, I just say divided by the 10 of 24, 47 equals, right, and again I'm thinking here, my answer will be certainly more than 13, about 30 maybe, 28.1, 28.2, 28.2 meters, 1 decimal place. Right. And our third one here. My angle, I've got the opposite and adjacent again. So this time I'm going to say tan of theta equals 9 over 10. Right, I've got to find theta. I can't divide this by tan. What I've got to do is undo that tan function. I've got to do the inverse tan of both sides. So theta is the inverse tan. That's what we use when we're finding an angle. And we write it like that. The inverse tan of 9 over 10. Okay. So out comes the calculator. Now what I've got to do is inverse a second function tan. The inverse tan of 9 over 10 brackets equals 4198. So it's about 42 degrees. I think is quite accurate enough. We could convert that using this DMS button. 49, 59, 14. But that's pretty close to 42 degrees. Nearest degree. Wonderful. So that should be a good summary of our basic right angle trigonometry for sine, cos and tan, including sometimes some inverse functions there. Now I just want to introduce a little bit more terminology here. Again, that should be familiar, but angles of elevation and depression. Right, because lots of questions rely on these. Angle of elevation is measured from the horizontal up to a line. Right, that's an angle of elevation, is that much there. Angle of depression is measured from the horizontal looking down to some object. So angle of elevation questions are often someone is observing, someone standing on the ground and they see a plane in the sky, or they look to the top of a tower or an antenna or something, right? And that's the angle of elevation, right? That they have to tilt their head back to see the top of that tower. If you were perhaps standing on top of a cliff looking at a ship on the ocean below, right, you would be tilting your head down. That's an angle of depression from the horizontal looking down there like that. Angles of elevation, angles of depression. You may get, in fact you'll likely get word problems without a diagram, so you've got to interpret those. And can I stress that you must draw a good diagram. Okay. Here's a question that invokes that. They have a plane, leaves its airport A, flies 500 meters to reach a height of 171 meters. Okay, so what do we have? My airport is here at A, and we're going to have A is on the ground. This is going to be the ground here, my horizontal ground. Leaves the airport A, flies 500 meters to reach a height of 171 meters. I reckon that means that it has gone 500 this way. Right, that's what my plane has done there. Where's my plane? Best part about this topic, I get to draw little aeroplanes and things. Oh, that's not my best aeroplane though. Right, there's my plane. It's gone 500 meters, and it is 171 meters above the ground. Righto. So, plane, there's my plane there at P. Right, it's gone 500 meters through the air. Right, and that's left at 171 meters above the ground. So the angle of elevation of the plane from the airport, that's this angle here. I'm going to call that theta. So, I have the opposite and the hypotenuse, so I'm going to say sine of theta is 171 over 500. Right, that means that theta is the inverse sine of 171 on 500. Calculator to the rescue, all clear. The inverse sine, second function sine of 171 divided by 500 equals 19.9. That looks very close to me to being 20 degrees. Right, now for part B, horizontal distance, I'm going to call this x, just the horizontal component of that. So this time, I have one side, two side, I've got a third side. I could, now that I've got that angle, I could use something like tan. Tan theta is opposite on adjacent, or cos theta is adjacent on hypotenuse. But if I can sort of make this suggestion, you want to avoid using one of your calculations in a subsequent question where you can avoid it, right? I don't actually need part A to answer part B. Right? It's going to have fewer rounding errors. I could very easily work out x here using Pythagoras' theorem. Okay, so x squared equals 500 squared minus 171 squared. But I'm finding a short side, so I'd take the other two squares away. So x squared equals 500 squared minus 171 squared. Make sure that's right. 500 squared minus 171 squared equals 220,759. And that means my horizontal distance is the square root of my last answer, like that, equals 470. Three significant figures. Right, 470 meters. Well, good. The diagram is very important. Right, set out you're working nice and neatly. The diagram can help you to estimate your answer so you can recognize when you've made a mistake. Rightio, well that's it for our first video. Hope you enjoyed that. A nice review of right angle trigonometry. See you in class, guys.